So we have another game, and it's all about decoding, and it's all about logic. So do you have a logical mind? Do you have an ability to decode this message? It's a cryptic code, and here's your key. There is your key to decode the code. So if you want to do that, we're doing this live, but you might want to pause and we'll come back to that later because I'm not going to actually decode it. I'll leave those there for now so you can write them down or come back to it later. I'm not going to decode the message, but there is a message in there, which is the official name of the game. So that's your first activity to do. And then the next thing is, it's all about the game. It's all about playing with maths and just starting a watch party for the other people. My name is Caroline. I'm from Bubbly Maths, and I'm here presenting activities that are created by AIMSEC, an organization in Africa that helps create courses for teachers for their professional development so they can be better teachers of maths, so that the children that they teach in disadvantaged and rural areas have a better chance they can rise themselves out of poverty. So by playing their games, you're helping support them and helping those children to have a future which is, if they want it, it expands their horizons, enables them to get to university, that sort of thing, and succeed in maths. So that's my higher purpose. And what we're going to do is play the game. I've managed to share. While I was doing that, I did manage to share. And the game, the next step of the game is this. Are you ready? So I'm going to come back to that in a minute. I'm going to move over here and draw you. Now this is for lower primary, upper primary. The idea is you're going to do this, right? Here's the challenge. It's a challenge. You've got these numbers, 2, 2, 3, 4, 5, and 6. And you've got to put them in those boxes. Sorry, lower primary, not upper primary. This is accessible to a lot of people. And it's a good way, even if it's like you think, well, that's too easy, just do it. Because what we're doing is we're getting you ready to do this bit that's not so easy. You ready? You got that one? I'm not going to put the solution up on here. I know you can do it. Write it down. If you haven't got it straight away, write it down, because I am now going to rub this out. I hope you wrote that down. You can always review the video to get those numbers back out again. Okay, I'm going to leave those up there because we're going to use those later. Now, well, we might need the other ones as well later as well. We'll see. So here's another puzzle. You ready? We've got another puzzle. Are you ready for this? Tell me what those numbers can be in order for, these are single digits, by the way. These are actual digits. So that's a unit digit. They're all single digits, and those are in the units. This is the tens, and this is in the units. That's worth 1, however many it is, and that's worth 10. Okay, that's just a note on top, just to be absolutely clear. A cannot be a number that's greater than 9. So if you can solve that one, that's your next one to solve. So put one number in place of A and one number in place of B and make that work. Now, when you've solved it, is there more than one solution? Can you find more than one way of making that work? And if you can, why? And if you can't, why? Right, so that's the next one. If you haven't made a note, that's all right. You can replay the video again. Now, do I still need the tens and units? The next one, well, we are going to the next walk. This is the next challenge. Ready? So actually, we're going to go to, I'm going to add one there. I should have thought about that before. So now we've got going to have units here We're going to have tens here, and we're going to have hundreds here. So under this, we've now got, here's your next challenge, B plus A equals A, C, C. That's one challenge. And then, so we need to replace each of these by a single digit number. And then the second challenge on this one, put it under here, so it's lined up. P, Q, Q, R plus to get Q, R, and Q. Now that is now a little bit more complicated. So if you're aged between up to age 11, and you might, some of you will be able to do it and some of you won't. It depends how old you are and what your experience is. But this is something you can take away and keep working on, even if you don't get it straight away. And older people, please don't solve it for a person that hasn't got it yet. Ask questions, substitute different numbers. There's only 10 numbers you can use. There's only 10 possibilities for each one. Can you see that? Make sure you can see what I'm writing. Yes, 4, 5, 6, 7, 8, and 9. Those are the only possible numbers for each of those. And you've got some of them repeated. And those repetitions, this is only 3 numbers in here. And you'll find that some are just not possible. So you maybe start with those 2 and remember that's got to be the same as that. So whatever you add onto that that number there has got to be the same as that number there. So have a go at those. And this is now aiming at upper primary, lower secondary. So between the ages of 9 and 13. So if you're younger than that, you can do it, great. But if you're not, then stick with the other ones. We've got other activities as well in our 10 o'clock for the early years. All right, so got that. You can replay the video to have another look at it. And now we're heading off to the older learners. So now we're going back to this here. I did post this to you last night. The question was, what is the relationship between these numbers? Now I will give you this one. The relationship between those numbers is that. The reason why I'm giving you that is because it gets really interesting now. So we're going to now I'm just having a look at what we've got there. Yeah, that's different. Okay, so I don't need to write those other letters down again. These are now going to be different. I'm going to now give you a couple more challenges, but we're now talking to so between the ages of 8 and 14 here. So the next challenge is going to replace those letters in these sums. There you go. I'm going to replace those letters to make that sum. Easy peasy lemon squeezy, right? Okay. The next one is okay, a little bit more challenging because that just have to do with subtraction. This one is a little bit more challenging. What we want you to see is how the numbers that go here affect whether or not we move from now we've got the thousands in here. We've got an extra, we're going to put 1,000 in there. That's our third row. We want you to see how, I mean, you know how, but it's really important with this game. It's really going to get you to grips with, if you had any doubts at all, or any hesitation at all, or any confusion at all with when you're transferring up to the next level from units to tens, tens to hundreds, hundreds to thousands, this game is going to really help with that, seriously help with that. And those of you that do have that quite clear, it's a fun game. It's a fun challenge. So the next question is, hold on one second. I've got a question here and okay, so I'm now going to solve this one. I'm now going to solve this original encrypted message. Hopefully you've gone back and solved it before you see this. Because the question, the next question needs that. So here's the question. When we're using the letter O here, that's a letter, not a number, the letter O. What are the restrictions on that letter O? This is the thing. So once you can analyze these, we've got a few copies, we've got a few doubled letters, we've got the letter O doubled, we've got the letter L doubled, and we've got the letter A doubled. Now these are all extremely relevant and important in solving this puzzle. So because what we want you to do is we want you to find other sums that work, but they have to follow, in other words, you'll find your own code. So you're going to say, well, okay, let's say F is 2, O is 7. You could just come up with numbers, just random numbers, and see if they work. T is 5, B is 1, A is, oh wait, A plus that has to equal A. Going to stop and think about A for a moment. Got to think about that. L is, again, L plus that has to equal M. All right, so we can make L whatever we want. Could be the same. They're going to be the same number. They're all different numbers. Ooh, they're all different numbers. And because it's a code, so every letter has its own number. And then G is, okay, G is going to be F plus B, but G is going to be determined by what happens over here. So maybe we should start with E. E is L plus T. Okay, so E is going to be 8. M is L plus 7. L plus 7. So wait a minute, that's going to be 10. Or maybe you need to think about it. So that's your task. And the thing is that there are 244 solutions that I know of. So you could make this a summer project. You could create a big poster that's your football game. And in that poster, be nice and systematic. And in the activity sheet, it's even started for you, so you might not want to look at that. You might just want to make your own grid, a nice big poster. You might need more than one for 244 solutions. Nice big sheet of paper or multiple A4s, and this could be one of your summer projects. It's the football game, and you can keep going and finding solutions. That's one of them for that. And you do want to be looking at how important what the number needs to be for O. And if you read the resource, it would be a good thing if this is facilitated by somebody older with somebody younger. So if you're an older learner, have a grown-up facilitator, so you're not seeing everything that's in the activity pack. So or just get on with it and find all the different ways that code can be solved with numbers. And so I do have, see, if I ask the question, I'm giving you the answer. So there are questions in here under upper secondary. I want you to have a go at this and then read what's in upper secondary. I don't want you to read it first. Upper secondary being 14 to 18-year-olds. Don't read it. Don't read it. Don't read the activity first. Do find out how many numbers and what are the numbers that that the O can be. It's confusing me. That's the letter O. What are the possible numbers that O can be? That's a nice big clue for you. You get that, it's really going to help you find all the solutions as well. And why is it that there are limited numbers that O can be? What are they and why? That's my question to you. And the reason why we're doing this activity is it helps you work systematically and efficiently, and which is useful no matter what you're doing. It's a skill that I'm still working on because I didn't learn it as a child. Whereas if you learn it now, then that will serve you very well for the rest of your life. It's a life skill. And it's logical thinking. You're looking at proving why, if you say, well, like, this is it, this is all these solutions, or these are the only possibilities for O, all these different things. Why are these the only the ones I did earlier? Did they have more than one solution? And if yes, what are they and why? And if no, what are they? Why? If no, why is it no? And it works on finding proofs. So that's the proofs. Understanding place value. Doing this activity and finding all the 244 options really gets you into place value and gets you to be very solid with it. It's and adding whole numbers. If you're working towards doing into thousands, this is a nice way of doing it, making it a puzzle at the same time. So that will really help you be much more fluent by the time you start school again in September. And so it's reasoning, working systematically, and you're thinking mathematically, so you're being proper mathematicians, being logical, giving explanations, perseverance. You get that whole poster done as a family. It doesn't have to be done as one. And you can get the younger learners to do the simple adding. And if they're not quite sure about, you know what, by the end of the summer, they'll be working on the place value and moving the bits over and realizing that 9 plus 3, they can do 4 plus 3, no problem. 9 plus 3, they know, they'll work out that it's 12, but then how do you do the next one? So you can actually, if they see it done loads of times, that will, and you can put the tens on the things on top, but you can get the whole family involved. So that's 1,000, that's worth 1,000, that's worth 100, that's worth 10, and that's worth 1. And so just get involved and do it together, and just ask, you can ask the younger learners. I can ask my grandson who's 5, I can ask him to add 9 to 3, and if necessary use dots and things. And so perseverance is huge. It's a massive life skill, and you'll get that from this. And learning independently, get everyone to then, once the poster, think your own thoughts, have your own ideas, and teaching others as well is a great way to learn independently. Working as a team, working everyone in the home, finding a way to involve everybody so that everybody learns. So I hope you're enjoying our activities. If you are, please share the videos, and please do tell everybody about the group. And we have the 2 YouTube channels. If you're on YouTube, you can subscribe, which doesn't cost anything. It's just so that you get notifications. You can ding the notification bell. That's on YouTube. We have the Maths Toys YouTube channel, which slowly but surely we're putting up the aiming high activities, all the ones that have the home learning activities, and then the bubbly maths, we put the lives up. I'm doing separate lives now because they're slightly different, but that's working. So thank you for joining us. I'm going to very quickly check with on Facebook. Henrik. Hi, Henrik. Henrik, I wanted to ask you, these, if you're giving codes for a clue, what is that called? Is that the key? I bet you know this. I know Hendrik knows this. If you send me a message, if this will disappear. If you send me a message on Facebook, is it the key? Is it the key to the puzzle, to solve the puzzle? That would be really helpful. Thank you, Hendrik. And Andy, hello. Trevor, hi. John Frosty Cooper, and my brother in Portugal, Pindi in South Africa. It's lovely to see you, Pindi. Salvo in Southend, and Russell. I don't know where you are, Russell, yet. I'll have to work it out. Thank you so much for joining me, and we'll see you at just before 10 for the early years. I had to do it slightly early today, and we'll do another a live at 10, but I've got to do the live recording itself at 10 to 10. So it'll be 10 to 10 will be when I'm actually here in the group live, and then we'll replay it at 10. Thank you very much for joining me. I've now got to find out how to stop this, the eternal problem. Right. Thank you for joining. See you at 10 if you join us. That's in 40 minutes. Or at, well, I'm going to actually start at 10 to 10. So see you in 30 minutes if you're joining us live. If not, see you at the next video. Thank you so much for being part of our maths challenges and games, and I hope you're just learning the joy and learning to enjoy doing mathematics. Thank you.